Example 11 is a nice one. We're basically using the idea that we know what A and B is to try and find an X and a Y. The other thing that we're using here is the fact that the unit vector I and J, the unit vector J, are linearly independent vectors. And why is that? It's because they're not parallel. We know that these vectors are perpendicular. Okay, so because we know that they're perpendicular, what that means is that we can then equate, so hence we can equate coefs of I and J. So in this example here, you've got A, which is xi plus 3j, and B, which is 8i plus 2yj. We've got A plus B. A plus B, it says here, is negative 2i plus 4j. So we know what the coefficients of I and j need to be. Now if we actually substitute our A and our B into here, in place of A and B, we've got xi plus 3j plus B, which is 8i plus 2yj, equals what we know, which is just going to fit here. It's a little bit short. So again, what I'm going to do here, the key thing, remember, would be it's something like this. To factorise the i's, so x plus 8, and to factorise the j's, so 3 plus 2y equals negative 2i plus 4j. And from here you can see straight away that we have two expressions. Expression 1 is the coefficients of I, so x plus 8 equals negative 2. And the second expression would be the coefficients of j, 3 plus 2y equals 4. Now it's a matter of solving for x and for y. For the first one, if you solve that, if you take the 8 to the other side, okay, you're going to find that you end up with x equals negative 10. Make a box around that. And for this one, we're going to have 2y equals, I'll take the 3 over 1, so y equals a half. So the question was asking us find the values of x and y. Oh, we've done that by equating the a plus b equals negative 2i plus 4j, by then substituting what we know into the expression, okay, and then equating the coefficients of I and the coefficients of j to get x equals negative 10 and y equals a half.